because the negative values don't change in sign. Okay, so this is just, all this is just basic understanding. So we're gonna graph it for real, but if you had to just do it by yourself, you would go to 1 and 1, and then 2, and then what? 1, 2, 3, 4, and then 3, and 1, 2, 3, 4, 5, 6, 7, 8, 9, and 4, and 10, 11, 12, 13, 14, 15, 16. And you're gonna get something that looks like that. And of course, since you know that the negatives are gonna do this exact same thing, and this is a very well-known function, x squared, right? It's a parabola, and I'm sure most of you have seen this before. If you haven't, good time to see it now. I'm gonna put it on the screen here. I'm just using this software because it draws much better pictures than I ever can, right? Because I'm not a great artist, but the software allows me to just take a quick plot here, and there it is. Make the window a little bit better. Yeah, it's not great. I'm just gonna go minus 10 to 10, just like it does. Remember your calculator does minus 10 to 10 as a standard by default setting. Okay, so there's minus 10 to 10. That looks a lot like what you would expect to see in a calculator if you were to graph x squared. Okay, so here it is, x squared. Like I said before, 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16. And when you go to the negative side, it's exactly the same, right? Because minus 1 squared is 1, and 2 is minus, okay. And who's seen this before somewhere in a math class? Right? Okay, and if you haven't, it's pretty easy to understand, isn't it? Okay, so now, on this worksheet thing that I just handed you, I put one over there for you too, by the way. Yeah, we have, the first question I think is what, domain?
Yes.
Okay, so let me get one for myself. We're gonna answer for all of these. What is the domain of this function? Okay, exactly, and who said that? You said that, Lily? Why do you say that?
Because it increases to, like, it doesn't stop.
Close,
On the other side.
close. What does the domain mean again? What does the main word domain mean?
The x's.
The x values. And how do we determine, without looking at a function, how do we determine what the domain is? Well, what do we not do? We don't divide by 0. We don't take the square root of a negative number. If you look at this function, do you see any division? None. So when we divide, we won't even be dividing. So dividing by 0 is what? Gone. How about the square root? Do you see this symbol anywhere up there? So there's no x that's going to cause me a problem. Does that make sense? Nothing is going to go into this function and go, oh, I can't do it, right? Had I had something down here like x minus 1, then positive 1 is going to create a what in the denominator? A 0. So we would have to remove that, but that's not there. So there's no problem. So therefore the domain is all real numbers. And how do we say all real numbers in math? God knows there's 10 different ways. But the integral notation way is this way. Another way is to say x is what? Minus infinity is less than x is less than infinity. That's a compound inequality that says exactly the same thing as this. You could say in English, all real numbers. And then you've got this other symbol, which is like some kind of bar with an R next to it, which all still means all real numbers. So we're going to stick with 1 though, so we all can be on the same page, okay? So this is what we're going to stick with, is minus infinity to infinity. Okay, so that's the domain. Now let's talk about the range. What does the range mean again?
The y's.
Okay, now for the y values, where's the lowest y value you see?
0.
And then it goes where? As far as you want to. So we're going to go from 0 to infinity. Why don't I have any negatives? Well, do you see anything down here in the negatives? No. And infinity always gets a parenthesis. What does the range, though, can I get to 0? Can it actually be 0 for x squared? So what does this take? Bracket. Does everybody understand what bracket means? Brackets like that, you can include the number. Okay, good. Okay. The next thing is increasing and decreasing. Now, one thing I'll tell you about increasing and decreasing is we never include that point where it changes, right? Right here, it's neither increasing or decreasing. We cannot include that point. But from minus infinity all the way to 0, what is this thing doing?
Decreasing.
Right, because we read from left to right, it's going what? So it's decreasing from minus infinity to 0. And both of those get parentheses. Just remember on increasing, decreasing answers, you always put parentheses. So therefore, it's increasing from where?
0 to negative.
Is that good? Is everybody good with that?
So why would you not include 0 with increasing,
Okay.
decreasing?
Where would you put it? Which one would you put it in? Is it increasing?
Oh, okay, okay.
And since it can't be in both, because then it's not well defined, right? It's gotta be in one or the other, and it can't fit in either one, do we leave it out?
Okay.
Okay. Symmetry, you guys know what symmetry is? How would you define the word symmetry if you had to? And I'm not looking for like, you know, some sort of exact answer, but it just in talking, just in.
It could be mirrored across axis.
It could be what?
It could be mirrored across
Yes,
axis.
so the human body has symmetry this way, right? I got an arm that matches an arm, a leg that matches a leg, and even though my face isn't perfect, there's still an ear and an ear, right? But am I symmetrical this way?
No.
No, I got legs down here and arms out, I look nothing like that. So what about this? Would you say it's symmetrical on the y-axis or the x-axis?
Why?
Clearly on the y, right? Because on the y-axis, if I was to fold this over, I'd have this right back again, right? So this is symmetrical with the y-axis. Awesome, okay? We're going to leave the local minimum off these things because that's really not important for this class. But for intercepts, this is kind of an important thing here. The intercepts are both 0, 0 for the y and the x. Do you see that? They hit the x-axis at both 0 and 0. And you see here, see how it hits the x-axis and the y-axis right there? Because it hits at the origin, it's called the parent function. That's important to understand. The parent function, because if I move this around, it's no longer gonna have, like if I just was to randomly draw one like this, right, it would have different x-intercepts, and the y-intercept would be way up here somewhere where it finally went that way, right, which could be way up there. So therefore, this one would not be at the it would have 2 x-intercepts and 1 y-intercept, and it would be crazy. But this particular one that we're looking at has only one intercept, which is the x and the y at 0, 0. And because of that, this is referred to as the parent. In other words, it's got a bunch of kids that come out of this when we start doing stuff to it. We can create other ones with it, but right now, this is a standard one, okay? And then if you don't mind, just draw a quick picture. It does not have to be perfect. I want you to make a U function just like this, so that you have a general idea that if you look and see on a piece of graph paper that it has that shape right there, which function are you gonna call that?
Parent.
Well, it won't be the
X
parent.
squared?
You're gonna call it x squared of some degree, right, or some, right. It's not the parent when it's way over here, but at least you know it's an x squared, because x squared has that U shape. Which, by the way, could also look like this, right? Because what would this be? This would be a negative value in front. And we'll get to all that, okay? But right now, just the parent function looks of the x squared looks like this one right here. So draw that, and I only need you not to be completely like understanding exactly what's happening with it, but to know that that function right there, did you see that U? You're gonna go, oh, that's a square function. Does that make sense? Okay. Next up is what?
Cube.
Okay.
What about the local minimum?
We're gonna leave that off. I just said that. So we're gonna leave that off, all right? Don't worry about that right now. Okay, so x cubed, and what's cubed mean? Multiply it times itself 3 times. What's 1 times 1 times 1 times 1? It's always gonna be 1, right? How about 2 cubed?
8,
3 cubed?
27?
4 cubed is 64, and 5 cubed is 125. And what happens when you cube a negative number? Minus 1 times minus 1 is positive 1, times minus 1 is negative 1. So minus 2 cubed will be minus 8, minus 3 cubed will be minus 27, minus 4 cubed will be minus 64. And what ends up happening here is something like this. It's going to grow faster than the square one, right? Because it's 3 times instead of just once. But on the negative side, it's gonna go down this time, like somebody took this thing and bent it down. Now, let me actually put it on there, so you're not seeing how terrible drawing in here. X raised to the third power. How did I do on my drawing?
Fine.
Okay, but not great. Okay, so let me get rid of x squared too, so you're not, being distracted by that. See how x cubed grows faster than x squared? Because you're 3 times in the number, not just 1 time thing, right? Like 2 times 2 times 2 is gonna be bigger than just 2 times 2. Okay, but also look how the negatives stay negatives this time. So if I get rid of that one, this is a cubic function. Now, the cubic function is often referred to as the S function, even though S would most likely be turned this way, but do you see the S turn? So people call it the S function, or just think of it as an S turn. See how it goes up this way, like right here to S? It's still, what is the intercept?
0, 0.
Exactly, and that's gonna be the same for all of these, by the way. If you wanna just run down the whole paper and put the intercepts as 0, 0, that's what makes these the parents. These are all the parents, and that's why the intersection is at the origin, right? The parent, the origin. Now, what is the domain of this function right here? It's not gonna change, minus infinity to infinity, because again, if I'm cubing a number, am I dividing by anything? No. Am I taking the square root of a negative number? I'm taking the square root, I'm not dividing. There's no number I can't cube, right? You pick a number, I can cube it. Might be ugly, but I can still do it, right? So therefore, the domain. Now, this time the range though, what changed on the range?
It's negative infinity to infinity.
Right, because remember the last one went what, up this way? This one goes down as far as you want and up as far as you want, right? So what's the range? Minus infinity to infinity this time. Does that make sense? Because you can go down as low as you want to and as up as high as you want to. So we'll put that here. Now here's where you get to sound like a really good mathematician. Listen to this. Where is it increasing? Say it louder. Right, because look, it's going up. Now at 0, it technically isn't going up for a brief moment, but it's still going up. So we say that it goes up the whole way. So it's increasing from minus infinity to infinity. And if you want to sound like a really smart mathematician, you know what you say? It's increasing on its entire domain, right? Which is the same thing, right? So it's increasing on its entire domain. You don't have to sound like that. You can just say it's increasing from minus infinity. But do you get what I'm saying? Like you see some mathematician walk in and go, oh, it's increasing on its entire domain. No, it's increasing on minus infinity to infinity, which happens to be the domain. But that's what it says. So where is it decreasing?
Nowhere.
Nowhere, none, because if it's increasing on its entire domain, what's left for it to decrease on? None, right? It's never going down. Okay, symmetry, that would be impressive, somebody told me.
The x-axis.
Close.
X
Yeah.
and Y axis?
What?
Across the X and Y axis?
Yes, and what's that called? You're right, but you're close.
Radio? No.
Some diagonal.
Yes,
Uh,
it's called the origin. It's symmetrical with the origin,
Oh.
which means x and y. If I flipped it over the x and the y, look, if I flipped this over the x, it would look like this on this side, right? And then flipped it over the y, that means it's symmetric with the origin. By the way, that also means it's an odd function. If you want to go back up here for the symmetry on the x squared is an even function. And it doesn't hurt that x raised to the second power is an even number, right? And x raised to the third power is an odd number, but that's not why it's odd and even. Even functions are symmetrical across the y-axis, odd functions are symmetrical across the origin. And the intercepts, we already said were what? You fill that in for all of them, right? Because that's all the same. Okay. So if you see this sort of shape right here, now if we make it negative, it can look like this. Negative just flips it over like that. But if you see this S shape, you're gonna say, oh, that's what? Probably a cubic. Make sense? Squares look like U's, cubics look like what? S's. I mean, this doesn't really look like an S, but it has an S turn. I mean, S looks like this, I know, but you can kind of see one there, right? Okay. Awesome. Okay, so we're good with the square and the cube? Up next is the square root function. Okay. Square root. Well, let's look at the table for a second. What's the square root of 1?
1.
And let's get rid of these ugly numbers because they're not gonna help us. What's the square root of 4?
2.
Square root of 9?
3.
Square root of 16? Square root of 25? And you get those numbers, right? So if I was to draw this without doing the picture, at 1, the square root is 1. At 4, the square root is 2. At 9, the square root is 3. At 0, the square root is 0. It's gonna have a shape like that, right there. Let me go ahead and throw it on here, so you can see what I'm talking about. Put it on there, and I'll give you the other one. Okay. Get this one here. Okay. Now, just looking at this right here, it's close to what I drew, they just moved, the words moved. What is the domain of this function? Why aren't you using any negative numbers?
You can't square root.
Not in the real number system anyways, you have to use complex numbers to do that. And remember, when you're seeing a graph, it's real number versus real number. It's not imaginary numbers over here. We have a different graph for that. So, you cannot take the square root, but can you take the square root of 0? What's the square root of 0? So, when we go to the domain, can we include 0? Absolutely. But always put a parenthesis on infinity, okay? How about the range?
0 to infinity.
Right, can I actually get 0 out of this?
Yes.
So it's the same thing, isn't it? Okay. Where is it increasing?
The whole way, the whole entire.
Yes, exactly. You see, Eduardo sounded like a mathematician. It's increasing on this entire domain, right? From 0 to infinity, including 0. Now, where is it decreasing? Well, if it's increasing on its whole domain, what's left over for it to decrease on? None, exactly. Any symmetry?
No.
No, none. Intercepts? Already told you, fill that in. Because it's in 0, 0, this makes it the what?
Parent.
Thank you. Okay. Now, when you see a shape like this, you're gonna know that it's probably a square root function. Could this be a cube root function though, too? Kind of, except can you take the cube root of a negative number? What's the cube root of -8? -2. Because -2 times -2 is positive 4 times -2 is -8, right? So the cubic will be like this, but also like this. You see what I mean? Okay. What's that? That's the next one. Hey, look at that. Yes.
Why would you include the 0 for increasing on this one, but not for the cube?
That is such a great question, Ellie. I can't believe you said that. Don't include the 0. Okay. This is stupid, and I'm sorry that I have to be the one to tell you this, but the definition of increasing. Think about a stairs. When you're about to walk up a stairs, like you're about to step on a stair, are you increasing yet?
No.
You're about to be, but when you're on the stairs, if you're increasing, there's a stair in front of you that's higher and a stair below you that's lower. Does that make sense? And when we get to 0 here, when I'm standing at 0, is there a stair behind me that's lower? No. So therefore, you're not technically increasing. You're about to be though. But, and I just said a few minutes ago, never use what? Brackets with increasing and decreasing? So she totally called me out, and you're completely correct, Ellie. Good job. Does that make sense? From 0 to infinity, because for these two right here, they should never have brackets. And I threw one on there right on the back, and she called me out, so it's correct. Okay? All right. Symmetry here is none, intercepts are 0, 0, and we're almost there, we're gonna finish this in just a second. What about the cubic function? Well, unfortunately, I gotta go to my calculator yet. This software doesn't like to do cubics very well, so I'll just pull up my calculator for a second, and you can look at it. Mine, you don't need to pull yours out. Gosh, you know how long it takes to load? No. Okay. I don't know why you wasn't put in the key root. Now, this particular one has a key root here, which you could also just raise it to the what, the 1/3, but since it has an X there, I'll put it in. And hit- Why am I hitting Zoom 6, by the way?
It's the default window.
Right, because I have no idea what we did yesterday with this window. And I think we screwed with it a little bit, right? Tried to get like further out on one window. If you, first time you graph on the calculator, if you always hit the default, you go straight to the, default window minus infinity to, I mean, minus 10 to 10, minus 10 to 10. I see
Is the square root function even or odd?
the square root function is neither even nor odd, because to be even or odd, you have to have symmetry over either the y-axis or the origin. And this thing has what symmetry?
No.
So therefore, it's neither even or odd. However, how about this one?
Yep.
What is this one?
Odd.
Why is it odd?
The origin.
Because it's symmetrical with the origin. Do you see that? In other words, if I flip it over the x and then flip it over the y, it will be the same. In other words, the behavior here is very similar to the behavior here. That makes it an odd function. Now, lots of functions are not even and odd, and to be even and odd, you kinda have to have some really good things happen, because if I took the u function, which is definitely even, and just moved it to the right a little bit, it would no longer be even or odd, right? Because it would no longer be so even and odd is a really kind of, not many functions are either even or odd, but the ones that are have lots of good properties, and we'll talk about that later. Just know the fact that this one is definitely what? Odd, because odd is symmetrical with the origin. Well, let's go ahead and fill these out. Let me get it all set up here. So this function is called the cube root, which you can write by putting a 3 here. The alternative, though, is x to the 1/3. Those are same thing. And you should know that in any chance that you go past this class and you have a calculator, go, oh, I need to take the cube root. Oh, it doesn't have a cube root. What do? Raise it to the 1/3. It's the same thing, and most calculators have a raise to button. That's like a standard issue on a calculator, right, to raise to a power. But having a cube root is not a standard issue thing. But now that you know you can raise it to a fraction, you always have whatever root you want. What if I want to take the 4th root? What do I raise it to?
Sorry.
1/4,
1/4. What about the 5th root?
1/5.
1/5. See how easy that is? If you know this is knowledge. This is something you can take from this class, okay? So what's the domain of this function? Well, if you look at it here, is every x accounted for? Yeah, so what do we say? How about the range, though? Yeah, even though it's gonna take an awful long time for this thing to get to infinity, but it's still going what? Up. It's just going to take a lot longer, right? Like way out in the parking lot before it gets really high, but it's still going up. And this way it's doing what? It's going down. So it will go as far as I need to eventually. Increasing? Come on, let's hear some smart.
The entire thing.
Yes! That's what I was waiting for. It's increasing on its entire domain. It's always going up. Up, 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 taking its time, but it's still going up. So since it's used up all the x's in the domain for increasing, what's left for decreasing?
None.
None, exactly. Symmetry,
Origin.
which makes this,
Odd.
right, ooh, intercepts, well, you should have already filled that out, because I told you all of them have this. That's what makes this, marriage, yes, you guys are awesome. Okay, last one, absolute value of x.
I know this one, it's the V.
It's what?
It's the V.
It is the v function, that's right. Okay, absolute value looks like this. On your TI-83s, it'll look like this. These are the same thing, absolute value has two lines next to it. On the calculator though, it'll say ABS. Doesn't mean analytic brake system, it means absolute value. Okay, so domain for the, well, let's see what it looks like first. The absolute value would be just like this. If we took the line y equals x and drew it, it would look like that. But when y equals to x at -3 and then we make it positive, right, because that's what absolute value does, it would be up here at 3. So basically it just does that. Takes that line and flips it up. Does that make sense? Let's take a look at what it looks like here. I have it. Go back to my other software here. Hopefully I have it something on here. Absolute value right here. Absolute value x. Let's do it on here. And then we'll get rid of this one, which is away. And you see what I mean? It makes that nice V function, right? Okay. And as you said, it's well known as the V. So what's its domain? Well, what number could you not take the absolute value of?
0.
You can, absolute value of 0 is 0.
It's negative infinity,
Right, there's no problem here. I can take the absolute value of whatever number I want to.
but the range
If you
is.
give me a number, I'll give you an absolute value, so I can minus infinity to 3, but the range is what?
0 to infinity.
Do I include 0?
Yes.
Yes, because the absolute value of 0 is 0. How about the increasing? From 0 to infinity, and the decreasing? Minus infinity to 0. Right, from minus infinity to 0, this thing is going down, and then from 0 to infinity, this thing is going up. Make sense? Symmetry,
X-axis, the Y-axis rather.
intercepts, you should have already filled out. Now do me a favor, and take a quick look at the first one we did, x squared, and compare it to what you just wrote for the absolute value of x. It should be exactly the same. And one's called the u function and one's called the v function. And they behave almost the same, except that the u function grows faster, right? You know what I mean by grow? Here, maybe this will make more sense. The u function, let me put it back on. X squared. Make it happen there. Why do you have to be like that? X to the second power. And I'll throw it back on here. Okay. You see this? Let's just say that you were investing money. Would you put your money in the blue one or the red one? Why would you put it in the red one? Because in a shorter amount of time, there's gonna be more money, right? So which one grows faster? Do you understand what I mean by grow now? Grow means get bigger quicker, right? It gets bigger faster. If I'm investing money, I'm putting it in this one. This one grows this way, which isn't bad. This one grows this way.
It's rate of increase.
The rate of increase is much higher, right? And that's the idea. I mean, not that money's everything in the world, but the reason people invest money is to do what? Make more money. So if you had a choice, you would choose the red one. Unless you just want to choose the blue one because you don't care. But none of us in this room think that way, right? I don't know, maybe you do. All right, so you guys have an idea now what these functions look like? If I drew one of these pictures on the board and went like this and said, hey, what do you think this looks like? What would you say?
S.
It's a cube function, right? Why did you say it? Because it's got the S term. So maybe next to the little cube function, you put a little note that says S term. The U function, which one is the U? Well, I just talked about it. What is it? Square function. The V,
Absolute value.
just one thing going up like this could be,
Square.
right, because the cube root would have what? The other side. Make sense? Okay, now you guys are experts. No, you might not be experts, but you get the idea, right? Okay. Now, there's stuff that happens to these functions that happens to all of them. Now, I'm gonna pick on x squared because x squared is one that we're all familiar with, okay? Everything I do here works for all of these functions, but I'm just gonna pick on x squared for a minute. alright? So let's talk about this. I got x squared on the screen right now anyway, so this is perfect. So x squared can be written like this. F of x is equal to a times x minus h squared plus k, where h comma k is the origin, well, let me just say the vertex. Because in our case, it's the vertex right here, happens to be the origin, right? The vertex, do you know what I mean by vertex? The lowest point, but maybe even the highest point too, if it goes like that. The vertex is that point where it's not either increasing or decreasing, it's like stopped for a moment. Okay. Even though we, or whatever. Okay, so in this case right here, if I let h equal to 0 and k equal to 0, then it would be a times x minus nothing squared plus k, which is nothing, right? And a is 1 because this is the parent, so I'll put 1 right here. So 1 times x minus nothing squared plus nothing is just x squared, right? X minus nothing is x.
So,
Did any of you guys come here last semester during the real semester? Like when this place was actually crowded?
Yeah.
Couple. Remember how people in the hallway would say stuff and we could all hear them talking?
Yeah.
I'm trying to warn my students, don't talk in the hallway stuff you don't want other people to hear, because we're all listening.
I remember one time the blind kid came in here, I think he was pushed.
Lots of
Oh,
stuff goes on, and I'm just saying, you're walking down the hallway and you're saying stuff, you're being heard, okay? Just warning. Not in the summer, because there's nobody here. Okay.
I have a math question.
Yes,
So if the,
thank God.
if the HK is the vertex, and HK is also used to denote the center point of a circle,
Yep.
but you said the vertex is the lowest point.
No, I said in this case, the lowest point.
Oh,
It can
okay.
also be the highest point, depending on whether it opens up or down.
Okay,
We'll
and,
get to that.
okay, so the vertex is different depending on the type of function.
Of course.
Okay.
Well, vertex and center are not the same thing.
Oh, but the HK is still used.
H stands for the
Okay.
because H and K denote a special point, right? H and K. we could
they're
put
just
what-
variables.
They're
right?
just like X and
Okay.
Y. There's like, but H and K are denoted as special points, like on a circle, the center, and on a parabola, the vertex. Now, I'm gonna write this again over here because this is important. I need you guys to really write this down right here. Okay. So there are, well, there's actually 1, 2, 3, 4, 5 things I can do to this. Looks like only 3, but there's actual 5, okay? But let's talk about the very first one. If I change k from 0 to something else, then it would look like this. X squared, let's say, well, technically it'd be x minus 0 squared, which is still x squared, right? But plus, say, pick a number.
5.
I take 5, I like 5, okay. I'm gonna take x squared plus 5, I'm gonna throw it up here on this graph. What do you think's gonna happen when I let go of this mouse?
Gonna go up 5.
It's gonna go up 5. So what does the k value do? Okay, what if I put minus 5? So this controls the what?
Y axis.
Vertical translation. Sorry for my bad handwriting, that says vertical. So therefore, if I was to come over here, let me just throw in a number like -2, just make it doable, -2, what's it gonna do when I throw it on there? It's gonna take the parent function, where's the parent function go to?
Origin.
The origin, right? What's it gonna do when I throw -2 on there? It's gonna drop it down -2. You see that? So, all I've done is change the k value on both of those, up 5 for the one that was +5, and -2 for the one that was -2. So k does what? Vertical shift or vertical translation. Okay. What do you think h does?
Mhm.
I mean, just using logic alone, if K does the vertical, then H should do what?
Horizontal.
Exactly, right, I mean, that's just common sense in a way, but let's talk about it. So this is gonna go back and forth right here, so that would be inside the parentheses, and we keep that one right there, let's do, again, I need a number from somebody,
7.
Would pick 7.
X minus 7. That's fine, and we're gonna square that thing, okay, that's cute. That's great. Okay, so X minus 7 squared, now I've changed the H value to what? So where is this gonna go?
Positive 7.
Well, how come it's not gonna go to negative 7? I put negative up there, right? Well, that's not exactly
Well,
what.
that is
What minus 7 is 0?
7.
So it's gonna go to positive 7, even though that says negative 7? It's just gonna go to positive 7. Let me throw it on there. So now, you guys need to help me help you. How do I write this? This has a horizontal translation. Okay, but it's counter to what you think. In other words, if it said plus 7, where would it go? Negatives by 7. If it says minus 7, it went to the, so can we say it's counterintuitive? It's a little bit opposite of what you think it should be, even though it's doing exactly what it's supposed to be doing. It still seems backwards, doesn't it? So if I'll put backwards here, and then I'll do it with quotation marks. It's not backwards. It seems backwards. Does that make sense? It's not doing anything backwards. It's doing exactly what it's supposed to do. But this clearly says minus 7, right? And where did it go? Positive 7. Now how about the K though? When I went up 5, did it go up 5? Yeah, the K's go just like they say they're going to go, but the H's go backward. They're not going backward, but they seem to go backward. Does that make sense? So I call it counterintuitive, counter to what you think it should do. Does the opposite of what you think it
Could you
should do.
say opposite sign?
It's the opposite sign.
I always think that the inside lies, like inside parentheses, lies.
Lies?
Yeah.
That's
So
a
like
big way
if
to
it
put
says
it.
-7, it's
Your
lies.
teacher taught you that in high school?
Mhm.
So she said that the inside of the parentheses lies. It's not lying, it's doing exactly what it's supposed to do, but it seems like it's wrong, right? It's backwards of what you're, so I call it counterintuitive. Counter to what you think it should be, but just know that. So I put words backwards here, but I put it in parentheses. I know you can't read my handwriting, so I'm gonna try. But backward, meaning that it's not doing what you think it should do. But now you know, if I put x minus 8 squared plus 7, what's this going to do to the parent?
Increase the X by 7.
So the increase the y by 7 and move it
Yeah, sorry, I didn't
to the positives by 8. And they act independently. So pick your favorite point on the graph. Keep it under 10.
2, 5.
2, 5. Okay, 2, 5. That means we have 5 for a k and what for the h? Negative 2. But that's positive 2. Because it's backwards. Does it make sense? So if I put x minus 2 and then plus 5, it's going to go right here, but it's going to look just like the parent. Does that make sense? So let's do that. Okay, x minus 2 squared plus 5. How did I do? Pretty bad.
You put it at 2, 4, but
Pretty bad. Yeah, I did really bad. But this is at 2.5, right? I put it at 2.4. But it's still opening upwards and looks way. Okay, so is everybody cool with what the H and the K does for this?
Yes,
What's the H do again?
horizontal,
What's the K do?
vertical translation.
And the H is
Back.
in what did I call the quotations? It's not backwards, but it seems backwards.
The H is for
The
horizontal.
inside lies, right? I like that. I'm stealing it from you. I've never heard that before, but it's perfect.
The H is for horizontal and the K is for the other one.
Yeah, there you go. I like that. H does sound like horizontal, right? Because H is horizontal. K is vertical, so the other one. I like that too. All right, so let's try another thing. Let's go back to the original one, which would have 0, 0 for h and k, so it would technically be x minus nothing squared plus nothing, also known as just x squared, right? Because x minus nothing is x, right? And plus nothing, you don't write. So this is the same thing as being in the what? Origin, or also known as the parent. Okay, but if I put a 2 in front of it?
That's the amplitude,
No, that's trigonometry,
sorry.
although you're in the right field. Okay, if I was to go to my garage and pull out some old inner tube from a bike that my kids fatten the tires on, right? And I put my foot on it and I hold it, could I make that shape, parent function? Could I make that, could I put my foot on the inner tube and make that shape? Yeah. And if I held it just right, I would make it just like an x squared function. What if I decided to pull it twice as hard? What's it gonna do? It's gonna go like this, it's gonna stretch up and get what? Narrower this way. It's called a stretch though, because we're stretching it up. Even though it looks like it's compressing this way, we're stretching it up. You guys have been to the gym, you pull those things, right, you know what I'm talking about? And if I was to reach down and grab this parent function with both hands and yank on it right this, what it's gonna do, it's gonna go, "Wah," right? So let's do that. Let's put a 2x squared on there. Oh, maybe if I can learn how to operate a dang computer. Stop it. That's better. Might not work. Okay, let me get rid of these other ones that are out of the way. Okay, so you see the new one there? I stretched that more. So what if I change that to 3x squared? I don't know if I can do it here. Let's try it here. Just do 5x squared. Let's really give it a good stretching. What's 5x squared gonna look like? See, the more that I add the number in the front, the more I multiply, what happens? The more I'm pulling it up. Do you see it? And if I did 10 and 11 and 12, what if I did 100x squared? It's gonna look like just two little lines going right up like that, right? What if I did 1/2 of an x squared?
To be wired.
Right, because if I'm holding that shape with that inner tube with my foot, and I let go half as much, what's it going to do? It's gonna go down, right? So let's see what happens.
Can the A term have an exponent, or does that turn into a different type of function?
Say it one more time, I didn't understand.
Can the A term have an exponent instead of being a?
Well, then it should be a bigger number.
Okay, so it's not going to
A
affect.
term's a
the
constant, so
Okay.
if you want to square it or cube it or put a number on it, it will just be bigger.
Okay,
That make sense?
yes.
Okay. All right, so, let me do, how about 0.5? That's 1/2, right? X squared, and see what that does. Doesn't like what I said. Right.
There's a comma there.
That's just one to me. That's why sometimes I don't like all this stuff with this. Try to see. 0.5x squared. So that's 1/2. Let's see what it looks like. And it's getting wider. What if I did say 0.01? What's that gonna look like?
A bowl.
A what? A bowl. Yes, yes. I would say the same thing. More bowl, see it? How far down? What if I did 0.00001?
Almost be a straight line.
Almost, right? What if I did 0x squared?
It would just be,
Well, 0x squared would still be just 0. And what does y equals 0 look like? It's called the x-axis, right? So if we put a small enough number, this thing finally, like we let go of that energy, just finally let it go, what's it gonna do? It's gonna land flat on the ground, right? That's what happens. As this number gets smaller, it goes this way. As the number gets bigger, it goes this way. Technically, though, it's going this way, okay? Because we're stretching it up. But visually, it's going to go this way, right? That's the visual thing of pulling it up. So it's called a stretch. Okay, so when A right here, absolute value of A is bigger than 1, we get a stretch. And when its absolute value of A is less than 1, we get what's called a compression. And the compression is what you're seeing here. This is a compression. See how it's being compressed towards the x-axis? Why did I say absolute value?
Because
if I
it's the
throw a
distance.
negative in front of the A, what's this whole thing? It's going to flip the x-axis, and everything I just said is the same, but upside down. Make sense? Okay, so the A controls stretching and compression. It also controls a negative is a flip over the x-axis. And one way you can think about this, the way I tell a lot of people, even though it sounds silly, is that when I have a positive value for A, what does this look like? What's that person doing? Smiling. A positive person smiles. A negative person
I feel like that was planned.
Was that, yeah?
That was planned, wasn't it?
let's throw a negative value in front of that. Negative x squared. You know it's just gonna go upside, oh, geez, I can't. There. See the negative value? What does it do? It makes the happy person to a frowny person. Negative people smile. I said that, didn't I? That came out of my mouth, didn't it? Negative people frown. Positive people smile. Negative frown, or opens downwards, positive opens upwards. Okay, so we're almost done with our little thing here. What does H do again? Horizontal, and it's counterintuitive, it lies. I like that. K, vertical, does it lie?
No.
No. What does A do? Well, two things. Controls the stretching this way or this way, which is called compression. And it also controls the what? Smile versus frown, or flipping over the x-axis. There's one thing left. If I put a negative inside here, this flips it over the y-axis. Let me write that better. If I wanted to flip something over the y-axis, I need to put a negative on the inside of this x. But if I flip the parent function around the y-axis, what's it going to look like? Well, look back at that chart we just did. What's the symmetry of the x squared function? The y-axis. So if I flip it over the y-axis, would you be able to tell? No. So that's why this is the only thing where this fails. You put x squared back on there real fast. Not 0. So here's my parent function. Now I'm going to put in parentheses negative x squared. Of course, I think the software is even going to laugh at me. Right, look, watch what happens when I hit enter. It just says, oh no, it's not laughing at me. Oh, because I put the square at the inside. Let me see. Yeah, this is where I'm going to put the square out here. Yeah. See what the software did? The software said, oh, you mean if you put a negative on the inside, it isn't doing anything, right? Even the software is laughing at me here, because when I graph negative x squared, it's going to just look like positive x squared, because it's not going to do anything. Now, hold on though. What about the square root of x, right? The square root of x goes this way, just for fun. At the moment, let me throw the square root of x on here. Okay, so we're going to add this to the graph. Get rid of this one. This is the square root of x. Look at your paper we just did earlier today, right? That's the square root of x. If I change that to the square root of negative x, since that's on the inside, it's going to go across the y. What if I put it on the outside? Well, that's what I'm doing here. Then I'm going to flip across the what? Okay, so let's do that first. I'm going to put a negative right here on the outside, the very front of it. Here's a negative. I'm going to put it up here. This is going to flip over the what?
Yes.
Boom. You see it? Did it flip over the x? Okay, now let me get rid of it. Now let me put the negative on the inside. outside. Okay, see how the negative's on the inside now? And I put it on here, what's gonna happen when I throw this on here?
What?
Flipped over the Y. Did you see that? Okay, so how do I flip it over the Y? Negative where? Inside. How do I flip it over the X? Negative outside. So let's write that down. Flip over X, negative outside. Flip over Y. Negative is where? Okay. Now, if you put a negative in the inside of a square and you flip it over the y-axis, this picture right here is the same flipped over the y-axis. You wouldn't be able to tell. But this one, the regular square root that we had, I put the negative on the inside, it flipped over the y. In other words, it went this way. When I put it on the outside, what did it do? It went this way. Let's do that again, okay? So you can see this. Okay, so taking the square root function right here, and I'm gonna put the negative in front, which is what? Outside of the function? You see what I mean by outside? It's not inside the symbols. What's it going to do? Go over what?
The x-axis.
Get it? Okay, you get rid of it. Now I'm gonna move the negative from the outside to the inside, this is what we call the inside here. Oops. Okay, whatever. I can't operate a computer. Okay, negative X, there we go. This one will do what?
Y.
So that way? Make sense? Okay, take a look at this one. What do I have there?
It's gonna go diagonal.
Okay, well, let's talk about
It's
this.
reflective of the
I
origin.
got a negative now on the inside and the outside. So the first thing that happens is always inside, right? The parentheses. So what's the first thing it's gonna do? Is flip over what? X. Then, because the negative is also on the outside, after it's flipped over the X, it's going to flip over the Y. Does that make sense? Yeah, see what happens. Is that what we expected? It flipped over the X this way, and then it flipped over the Y and went like that. Well, it's not a good order, sorry. But do you see it now? Okay. There is one other thing that does happen with functions, and that's a horizontal compression and stretching, but good news for you is we do that in pre-calc, okay? We're not gonna fool with horizontal.
Thank God.
Right, because you got enough, right? You got enough. All right. So, quick question here. Going back to our friend x squared. Now that you know some of this information right here. Okay. F of x or y. If you saw this function right here, and I asked you to graph it, let's talk about what it would look like on a piece of graph paper. So let me start with the parent function x squared, so we have it. Here's the parent, here's the original. Okay, now look at this one I just wrote right here. What's going to happen to this one right here compared to the original?
It's going to be positive.
Positive 3, but that says negative 3. Right, so it's going to go over to positive 3, 1, 2, 3. What else is it going to do? Go up 1. And then that would be the original, but what's that 2 do?
It's gonna narrow it.
Okay, so it'll be a little bit more like this, right? Compared to what we had. So if I type that into here, I should look something like that. Does that make sense? Does it?
Yeah.
Okay. Let's see. So we have 2 x minus what? What did I write?
3.
Minus 3. that whole thing squared, that's how I know it's the U function, and plus 1. So if I have any good skills at all, how good was I? Do you accept that?
I don't
You
see
gotta- you gotta
anything.
put it there.
Pretty good.
Right? Could you do that?
No.
Yes, you can. Okay, no, you can. Here, I'll tell you what. Christopher. Pick me an A.
Six. Two, three.
Three. Okay, H can be bigger. Right.
5,
And a K.
7,
You wanna go negative on it?
no.
Okay, plus 7. Okay, all right, so -5 means it'll go where? +5. And the 7 means it's gonna go
Plus 7.
right there. It's still positive, so it's gonna open up, and what's that 3 gonna do?
Stretch.
Yeah, like way something, I over-exaggerate. But something like that, do you feel comfortable with that?
Yeah.
So let's find out. We can put in there 5. And then +7. Okay, here we go. What do you think? Not perfect, but I can live with it. That's a pretty good shot at graphing something. Okay. All right. One more question for you.
You saw what we're doing works with all the functions, right?
Yeah, everything we're doing, I'm just picking on X squared because you guys know it's so up.
Supposedly.
Okay. Pick a better number. Do 6. Okay. So, you haven't had a conversation with me at all today. You walked through this door, and I said, put your graphing calculator down and graph that. Okay. What would you do?
You didn't teach me how to do that. I got in here today. Sorry.
Do you would solve the quadratic to get your x-intercept.
That's one way to do it.
I want to factor it.
Factoring would be a good idea too, but let me show you another alternative. Just think about this for a second. Watch this. If I was to take x squared minus 6x and to add 9 right here,
You can play this way.
it's half of 6. But then I subtracted 9. Now, don't get mad at me. What does plus 9 minus 9 do?
Cancel.
Cancel each other. So did it do anything to this function? I added 0 to it. But because this stuff is, let me make this plus 8 so it works out better, okay? Can you change that to plus 8? Look at this right here. What is that? X minus, and then what is minus 8 plus 9? Okay, so now what's the function doing? It's going 3 into the positives and down 1, and opening upward because this is still 1. I just changed this to look like this, and I just graphed this thing without having to do anything. Okay, let's take a look at what that looks like on a piece of graph. We're gonna do several of these, don't worry. So what did I say I did? What was the thing I said? X squared
X squared minus 6x.
minus 6x, and then I said, whoop, not like that. Sorry. X squared minus 6x plus 8, right?
Yep.
I changed it to plus 8. Okay, let's see if that works. Let me get rid of these because they're in the way. Okay, we'll throw this on there. And see what happened? It went over to the what? 3 and down 1. Over 3 and down 1. By doing what process did I use?
So take a square.
being the square comes in everything we do in math. That's why we have to teach it to you guys. I was able to complete the square and take something that you had no exact idea what it looked like and make it into something you have everything you know it looks like. You could graph these things now. This is like the graphing calculator of, the ancient times. They used to do this on clay tablets, by the way. The Sumerians used to do this. But anyways, let's try another one, okay? Let's try one more, so. There's a parent function. We're going to do x squared, we're going to do plus 8x plus 20. Okay. Two numbers that multiply to 20 and add to 8. No, that's not going to work out, but it doesn't matter. So 8x squared plus 8x plus 20. And I said to you, hey, graph that function. You could find the intercepts. You could find the y-intercept, which, by the way, is 20, right? It's going to be hard to graph. And then you could look at a table of values, or you could be slicker than all that and do what?
Plus minus 16.
Right, let's do that. Okay, so x squared plus 8x, I'm going to add 16. Now, can I just add 16 to a function because I want to? Call your bank and say, hey, just throw $16 in my account and see what they say, right? Now, we'll take it from somewhere else, right? So what do I have to put here? Minus 16. And then what's already there? Okay, now what is about addition and subtraction is good is it's called what? Associative. I can do this, which becomes x plus 4 squared. And what is 20 take away 16? 4. Okay, so what has this function done? It's gone 4 to the what? Negative 4, and then what? Okay. 1, 2, 3, 4, and then 1, 2, 3, 4. I'm trying to make it here. Is it still positive out front?
Yep.
So as I put a number in front of it here, an A, to make it stretch, so it's going to look a lot like the original. I should be pretty close, don't you think? I just graphed this thing on here without touching a graphing calculator. Let's see how it goes. X squared plus 8x plus 1. Oh, come on. There, okay? Alrighty. I'll live with it. Not perfect, but I was pretty damn close, right? See how this works? Okay. It's kind of weird to get used to adding and subtracting the same thing from a function. It's not a normal thing to do. If we look at the homeworks now, there's still one more part I need to teach you, but let's see if I can get there. I know we were on homework 5, right? That's the one with the. I thought we did homework. Come back to that. I purposely skipped over that. We're not going to skip it. We're going to do it. Not that one. I skipped homework 5, but we're not skipping it. We're going to do it in class. Don't get me wrong. No, it's not homework 6.
Probably like 20 parts to it.
Probably. It's never good. Maybe it's homework 5. I'd say we are on the right homework. The beginning of this homework has some pretty crazy things though, but, all right, so take a look at this right here. You're gonna need to know how to do this. This is actually not something that, this is something you're gonna wanna know how to do if you do any math at all in the world. Take a look at x squared minus 6x plus 8. The first thing I want you to notice is that this is ax squared plus bx plus c, and this is a times x minus h plus k squared. Notice the value of a and the value of a do not change. So what's the value of a here? What's the value of a here? Make sense? A does not change ever. Okay. How do I find out this number here though? Well, I'm gonna take x squared minus 6x plus 8. I'm gonna rewrite it as x squared minus 6x. What do I wanna see right here to complete the square?
9.
Does everybody understand? We took a test on this. You take half of 6 minus 3 squared is what?
9.
Okay, now can I just throw a 9 there? So how do I compensate? Turn right around and subtract it. But then there's still a what there? Okay, is everybody good with that step? Okay, now we're going to use the associative property, and this becomes x minus 3 squared plus, or actually minus, right? Because minus 9 plus 8 is what? Okay, so what goes in here? Well, see, there's a minus sign already there, so what goes in this box? What goes in here? That says plus, it says, so what? Make sense? Does that make sense? Okay. Plus minus 3 minus 1. Well, the 3's already got the negative, so 3 negative 1. And then if we wanted to graph this thing, I'm gonna hit this. What kind of picture does the square make? We just went over this today.
Oh, U.
Okay, which one of these is a U?
The one that looks like a
One that looks like
U.
a U, right, okay. And where do I go? It says minus 3, so do I go to minus 3?
No, there is.
Positive 3, but then I do what?
Down 1.
Why am I going down? Because the K does what it says, and the inside, what is it, Ellie? Lies. So what do we have here? Vertical shift, horizontal. Horizontal first goes what? To the positives by 3, and then the vertical is down by 1. And is there any reflection over the x-axis? Is there a negative out front? Does the x have a negative on it in the inside of the parentheses? So none of those, so we should be good. Yes?
I have a question from like 15 minutes ago, but say there's like a function, but isn't on the origin, but it has to be flipped over the x-axis. Do you flip it like this, or do you flip it like over its vertex? You know?
The thing that I want to say to you beforehand is, do you know what this means?
And does.
Okay. So when we look at this right here, what's the first thing that's going to happen?
It's gonna shift.
Left or right?
Yeah.
Then what's the next thing that's going to happen?
Then it's gonna go up.
The flip or over the flip.
Oh, okay.
So the flip is the second thing.
Okay.
Does that help you? And then it moves out here, because this is the last thing that happens.
Okay.
Okay? So just think PEMDAS. It's an excellent question, by the way, you guys.
Yeah, can you say it slower?
No.
But then, like, so this is.
There's this
Wait.
thing. Gosh,
So this is the y-axis, and it's like over here. Does it flip like this, or does it flip like that? You know?
it's over the y-axis, so how far away from the y-axis, it'll go to the other side of the same amount, yes.
Okay.
And you don't need to worry about that right now, Sarah, so I'm not
Okay.
being silly, we'll get to this. I've given you a ton of information today, okay, so I don't need to go much further. But there's really 2 more things, but more importantly, 1 more thing. This one right here. Okay, notice that in this problem, we added 9 and subtracted 9. Now, what do we usually do when we have what are the steps for completing square? Step 1, divide, make sure A is 1. Step 2 was to move the constant, and step 3 was to add to something to both sides. The reason I have to do a plus 9 and minus 9 because there's not 2 sides. I don't have another side. Now, step 1 means that A should be what?
1.
One.
Okay, and if you look up here, in this problem, is A equal to 1?
No.
So normally we would divide 3 by 3, right? But we can't divide 3 because if I just take a number, take your bank account, and divide it into thirds, are you gonna be happy? Why? Because it'll be a third smaller than it was, right? Now, if you were to divide the one that the bank, the loan that you owed by a third, then it would all work out. But since there's no equals to, don't look at that, it's just a definition, we don't mess with f of x, okay? It's really just an expression. There's no equals to sign, so I can't divide both sides by 3 because there's not a both sides. So what's the next best thing we can do? This is gonna kind of freak you out a little bit, but just watch. I'm gonna pull that 3 off. But I'm not going to let the 29 get touched. Now look at this carefully. 3 times x squared is what?
3x squared,
3 times minus 6,
negative
and
18x.
that plus 29 is out there. Is this the same as this?
Mhm.
It is. You see how I left the 29 outside? Now, what should I, is this a 1 now?
Mhm.
What should I add in here? Why am I adding 9? Let me do a different color so you can see. Why am I adding 9? Because half of 6 is 3, and 3 squared is what? What do I have to do in here? Is everybody good so far? Now, this is in my way. I want it out of the parentheses. So I'm gonna take this 3 and I'm gonna bounce it out. So what happens is I get 3 times x squared minus 6x plus 9. What's 3 times minus 9?
Negative 27.
And then here I got plus 29. So this came from this right here. I took 3 times minus 9, which is minus 27. And now this becomes 3 times x minus 3 squared. What is 29 take away 27? 2. So what goes here? You notice it didn't change, right? A always goes, A never changes. It's still there. So this is what? What's this number right here? Well, it says minus sign, that says minus, so what do I put here?
3.
And what do I put outside? 2. How do I get that 2? 3 times minus 9 is minus 27. 29 take away 27 is 2. Let's see if it works. 3, 3, 2. Now, if you want to graph it, I just hit the U button. Get this little window that comes up. What's the vertical compression? What's the A value? The vertical compression or stretch, what is it?
3.
Now remember, some of these could have been negative, but the negative does what? Flips it over the x-axis. So when it comes to the vertical stretch or compression, the answer to these questions are always positive. I either stretch it up by 3 or I stretch it down by 3. I don't ever stretch it by negative values. The negative is going to flip it over the x-axis. Does that make sense? So the answer inside here is always whatever A is in absolute value. That's why I put absolute value right there. So what number goes up there?
3.
Okay. And then, we're not doing horizontal stretching. Okay, vertical. Actually, horizontal would be here. What's the horizontal on that one?
Plus 3.
Plus 3, because it says negative 3, right? Does everybody understand why I'm going plus 3? And then what's the vertical?
2.
Plus 2. There. Does that look good? Any reflections?
No.
Voodoo math, adding and subtracting, and then bouncing numbers out of parentheses. Where have you ever heard that before?
How come you can't?
Go ahead, Chris. I understand it's weird.
Well, so the 3, what, if you distribute it to the negative 9, why can't you do it to everything else?
You can, but you will lose your, the whole point of doing this was to have this.
Yeah, I get that, but
Let's go ahead and distribute it, let's do it. 3x squared minus 18x plus 27 minus 27 plus 29. These cancel, you're right back to where you started.
but when you have the parentheses and the number outside, don't you supposed to distribute everything that's inside of it to the number outside?
That's what you learned a long time ago, huh?
Yeah.
How about this? Is that my phone? Sorry, time to get up. Okay. Yes, when you have a number outside, you're supposed to do what? Distribute it? What we're doing is being selective with our distributing. We're not distributing all of it because we wanna keep these in, we're just distributing to one of them. Why am I want this one out of here? Because this trinomial is what makes this x minus 3 happen. With that minus 9 in there, that's in my way. And technically, if I have it in here, those cancel back out to 0. And the reason it's green is because I put them in there. I put the plus 9 there because I wanted it. And since I don't have another side that goes plus 9 on the other, I have to turn around and subtract it. Now I'm kicking it out. And I'm kicking it out by doing a semi-distributive property. I'm just distributing to one value inside the parentheses, not all. Nobody ever taught you you could be selective about it, huh? They said you had to do it all. Now you learn differently. You can choose. And I choose the -9. Why do I choose the -9? Because I don't want it in there. Because if it's in there, I can't do this. Does that make sense?
I get it. I
A
just,
little bit?
I don't know about the
Listen,
select.
it's, I know. It's always weird when people see this for the first time. And nobody else, no, I say that. I often call this voodoo math because it is counterintuitive what you think you should be able to do. You're supposed to what, distribute to everything inside the parentheses. Nobody ever told you you could just choose what you wanted. It doesn't change anything. Those are still in the parentheses, and if I wanted to distribute, I could. I just did one of it and stopped. I didn't do all of it. Why didn't I do all of it? Because I wanted that in there. I wanted to keep what I wanted to get rid of what I didn't.
But that changes if it's not addition and subtraction, correct?
Well, of course, yeah, of course. Addition and subtraction is what's more making this work. You throw multiplication in there, we got problems. Okay.
Okay, can I just, so you do what you would do when you complete the square, you
Correct.
know, and then.
You add
You'll-
that number and
yeah.
then you turn right around and subtract it.
And so like we pull out that common factor and we just distribute it
The
to
last
minus b over 2 squared. And that's
Exactly.
it.
That's it, yes, yes.
Okay.
100% correct.
Okay.
Did you hear what she said?
And so it does all the rules, they don't matter. Just do that.
I'm not breaking any rules. I'm being selective with my distributedness.
I'm just
Because-
trying to put it in like layman's
no, I
terms
got
in my
you.
head.
Well, wait a minute. I'll wait till tomorrow. I don't know if to blow you guys' mind, but I think I've done enough today.
He's about to
We'll
put
call
up,
it right here.
he's about to do a 3 over 2.
What's that? No, I'm. Listen, no, this is fraction.
Your A is 3 over 2.
All right, hold on, I'm challenging you, I'm gonna tell you this right now. Oh, shit. Okay,
What happened?
watch this. What do you think A is gonna do?
2,
Okay, what do you think is gonna go in here?
4.
I'm gonna go with 2. Okay, and what do you think K is gonna be? Minus 4. Either way. 2 minus 2 is 4. What did I say, 2? Minus 2, right? What?
Oh,
And then this one was what?
Minus 4.
Damn. Why am I wrong? Hold on, let's see, what is, hold on. Wait, hold on. 8, 1, 8. Oh, 4. No, that is 4.
Is it just right
Elliot
before?
said
Is it-
4,
is it
and you
just-
said
is it
no,
just-
it's 2.
It was positive 4. Anyways, I have a formula that I'm gonna show you guys soon. That works every time. It's my own development, by the way. But it works every time. I can bypass all this reading now. Did you see how I just did that?
You should copyright it.
I should. See you guys tomorrow.
Can I ask,
You can ask what it is.
what are
One thing
the,
is test.
yeah, and like, what homeworks is it gonna cover? Like, what order should we be doing these homeworks in, since you're all over the place?
3 through 5?
I'm not really all over the place, but I guess it looks like I am, so let me show you.
I mean, you know, like skipping homeworks.
Oh,
I don't mean you're like
We did 4.
disorganized.
okay, so,
The test is all the way through.
Through 4?
yeah.
Okay.
Two more. Well, we did one